Hi everyone, this is example 14 from chapter 13 in your student packet. It says, a survey of shoppers is planned to see what percentage use credit cards. Prior surveys suggest 53% of shoppers use credit cards. How many randomly selected shoppers must we survey in order to estimate the proportion of shoppers who use credit cards to within 3% with 98% confidence? So what this is saying is, before we ever take a sample, we should figure out what our margin of error is and how confident we want to be. And then using that information, we can figure out how big of a sample we should take in the first place. So we're going to use the formula for margin of error, where margin of error equals z star times the square root of p hat q hat over n. Now I know we haven't used this very much because we've been using our calculator, or we've been using the idea of margin of error to figure it out instead of this formula, but we definitely need this for this problem. So in this case we're looking for the sample size, and the sample size is n. So if I solve this equation for n, I will get n equal to z star squared times p hat q hat over the margin of error squared. You should memorize this formula. I don't want you to go through and do the algebra of solving for it. Just make sure you have this formula on hand. So we need to find all of the values for our variables here. So we're told the margin of error. We know that the margin of error is 3% or 0.03. We know an approximate p hat because prior surveys have given a proportion of 53%. So that's what we're going to use for the p hat. So this is going to be 0.53. And then remember that q hat is the complement of this, or 1 minus p hat. So 1 minus 0.53 is 0.47. The hardest part to figure out is z star. So z star is it's the z-score associated with the central 98% with your normal distribution. So I want you to imagine our normal curve. Then if this is the population proportion, then z star is this z-score such that this here is the central 98%. Now, we're going to use inverse norm, and with inverse norm, if you have a regular TI-84 plus or a TI-83, then for inverse norm, it only uses the lower percentage. This 98% is not a lower percentage, it's a central percentage. We have 1% left on either end of this, which means that for this particular z star, the lower percentage is 99%. So we're going to do inverse norm with 99%. And then this is a z-score, so our mean is 0 and our standard deviation is 1. And when you do this, you will get a z-star of 2.326. So now we have all of our values. We just plug them in and find n. So n is going to be this 2.326 squared times 0.53, oops, forgot my 3, times 0.47, all over the margin of error squared, so 0.03 squared. And when you put that in your calculator, you will get 1,497.44. But remember that n is a sample size. So this is the number of shoppers that we want to sample, and we can't sample 0.44 shoppers. So we need to round this to a whole number. But we want to be careful because we want to make sure that we do the best we can to meet this margin of error of 3%. So the larger the sample, the smaller the error. So we're always going to round up. So I just want to write that down here. Always round up. And so when we round this, we're going to get an answer of 1,498 should be our sample size.